Okay, guys, so we are going to be working on an angle projectile motion problem. This is number 2 from your homework. Okay, so a hunter is practicing hitting a target that is downrange. If the arrow leaves the bow at a velocity of 30 meters per second at an angle 40 degrees above horizontal, let's calculate three things. How much time it takes for the arrow to return to bow level, find out how far downrange the arrow goes, and what is the maximum altitude the arrow reaches. Okay, so the best way you can do this to conceptualize this problem is essentially draw a picture. Okay, so here we have this bow, this arrow that is shot from here at an angle, and it travels a motion similar to that. Okay, so here we know that it's shot at an angle. That specific angle is 40 degrees. Okay, so 40 degrees. That is horizontal. That is the ground. Um, and it's shot at 30 meters per second. So, when we're doing a problem like this, we know a couple of things. They tell us the initial velocity and they tell us the direction in which it's shot. The other thing that we know from projectiles is that at the very top of its path, the velocity in the y direction. So in the y direction, the velocity is equal to 0. So the way we show that is Vy is equal to 0 meters per second. So in this case, at this very moment, the velocity in the x direction is all the component from the initial velocity. So if you recall, there's no acceleration in the x direction. The only acceleration that occurs in this problem is the acceleration due to gravity, which is 9.8. So let's go ahead and start breaking these down into the three problems that we should look at. So first, when we're looking at this specific problem, there's three things. We need to look at the problem regarding the x direction. So if I set my axes, I'm going to set this equals x, this is y. So anything that's going up and down, anything that is vertical is y direction, anything that is horizontal is the x direction. So in the x direction, there are a few unknowns, and then I like breaking this problem down from when the ball was shot to the top of its path. I'm going to consider that part of the problem y1. And from when the ball is at the very top, so when there's no velocity in the y direction, when there's no velocity in the y direction, so when it falls, I'm going to consider that y2. Okay, so now there are knowns and unknowns regarding each specific portion of this problem. Okay, so the first thing that we need to do is that we need to break this down into its components. Okay, so we have an angle. I'm going to break it down into an x and y component. So here we have a 40-degree angle. We're trying to find the x component, which is the arrow I just drew, and the y component. So how do we do that? Well, we use SOHCAHTOA. Now, if you recall, the sine of theta is equal to the opposite over the hypotenuse. The cosine of theta is equal to the adjacent over the hypotenuse. So what hypotenuse? I said hypotenuse and wrote a. So this is opposite. Okay, so in this case, what we have here is we have 30 sine of 40 is going to give me the velocity in the y direction for y1, right? So we're looking at this portion of the graph. So then we go 30 cosine of 40 and the velocity in the x direction. Okay, so now that we have those, we can determine the knowns and unknowns in this portion of the problem. So the knowns and unknowns in x, the initial velocity in x is equal to 30 cosine of 40. Let me draw this just so I'll move this over. The initial velocity in the y direction, so Vy1, is equal to 30 sine of 40 degrees. Okay, so that's our initial velocity. Our final velocity in the x, so final velocity velocity final in the x is equal to the same, right? So there's no acceleration, so it's going to be the same. 30 cosine 40. So the acceleration in the x is 0 meters per second squared. Meters per second squared. And then we have the distance that it traveled in the x and the time. So the distance that it traveled in the x is unknown. We don't know that. And we do not know the time. Okay. So same thing. So what is the velocity in y1? Final velocity in y1. So the final velocity in y1. This is 0. So when it reaches this top here, what is the velocity? We said 0 meters per second. So the acceleration is equal to a negative 9.8 meters per second. The reason why it's negative is that the acceleration is pointing down. Acceleration is pointing down as the velocity is pointing up. So think of it that way. Anytime you have opposite velocity, opposite acceleration, you have to have the acceleration in the negative direction. So if it's slowing down, it's in the negative direction. If it's speeding up, regardless of whatever axis you have, then you can have it in the positive direction. Distance, we don't know. So distance, I'm just going to say h, the h, we do not know that, and the time, we do not know. Okay, good. So now when we go to y2, let's write our knowns and unknowns for that. So what is our initial velocity in y2? That is 0 meters per second. So the initial velocity at this moment here is 0, and then we don't know the final velocity. Well, we do know the final velocity, but in this case, it's not. We don't need it to determine it. So if there is a shortcut to these problems, and I'll show you that in class tomorrow. But for right now, I want you guys to break it down in this manner. So velocity final in y2, let's say we do not know it, although we do know that if it leaves, it's going to come back. So it has to come back at the same velocity. So essentially, it's the velocity in the initial, but I'll explain that tomorrow in class, so don't worry about that. Acceleration is 9.8. It's positive in this portion because the acceleration is pointing in the same direction. So acceleration is pointing down. You are also moving in the downward fashion. So in this case, acceleration would be positive. So distance, so the height we do not know, and time we do not know. So okay, now that we have these problems, we can determine. We have the knowns and unknowns. We can determine. We can start finding our unknowns using our kinematics equations. Okay, so if we have, I'm just going to write down my kinematics equations right here. I'm going to draw a line and draw my kinematics equation. So distance equal to v initial times time plus 1/2 at squared. V final equal to v initial plus at v final squared is equal to v initial squared plus 2ad, and then distance is equal to v initial plus v final all over 2 times time. Okay, so regarding, I'm going to work in y1 now. So in class, we know that the same time that it goes up is going to be the same time that it goes down. So these two are going to be equal to each other, and then the time in the x is going to be at both the time in y1 and time in y2 added together. Okay, so I'm going to work in y1. I'm going to try to determine the distance. Okay, so this will be find out how far, what is the maximum altitude. So this is c. Okay, so in order to determine c, what we do is we use a kinematic equation. So the kinematic equation we can use is v final squared is equal to v initial squared plus 2ad. So v final squared, again, this is all in y1, is equal to v initial squared in y1 plus 2ad. So let's just plug in problems. So again, I'm working on y1. So here my final velocity is 0. So this goes to 0. So this would be 0. My initial velocity is 30 sine 40. That whole thing squared plus 2 times the negative 9.8 times distance. Good. So when we work this out, we will have. So when we work this out, we will have 30 sine 40. That quantity is 19.23. Square that quantity, and you get 371.85 minus 19.6. So here you would move 370. So 371.85 is equal to negative 19.16 d. So divide this quantity by 19.6, negative 19.6, and you get 18.97 meters, and that's the maximum altitude it reaches. So you see the answer here is 19. I got rounded. This rounded is 19 meters. Good. Okay, so now we have the altitude. Now we could determine the time. So the time you can either work in y1 or y2. So let's go ahead and work in y1. So in y1, we determined this distance to be 19 meters. So in y1 time, so we have, we can use this equation here essentially. So the initial velocity, again, so, or you can also determine time based out of this here. So let's do that. So final velocity is 0 is equal to the initial velocity in y1, which is 30 sine 40 plus at. So we know acceleration is negative 9.8 times time. So 30 sine 40 we said was 19.23, and I found that from over here, did the same calculations there, is equal to negative 9.8. So 19.23. So 19.23 divided by 9.8. So this will give me 1.96 seconds in T1. This equals time in Y1. Okay, so seconds in Y1. Good. So we know from class that if the time in Y1 is exactly going to be the same time in Y2 if they travel the same distance up and down. So here all I need to do is multiply this by 2, and I get the total amount of time in the x direction is 3.92. So this is the total travel time that the projectile had. Okay. The next thing that it asks, and I think this is the last one, is what is the distance traveled? What is the range? So how far did it go? So what we do here in the x, we now have the time that it took. So we just essentially go use the kinematics equation. B is equal to v initial time plus 1/2 at squared. So here we have essentially acceleration is 0, so this will cancel out. We have distance is equal to the initial velocity in the x direction, which is 30 cosine 40 times time, and our time is 3.92 seconds. So when you do this all together, I calculated my answer to be 90.08 meters. So my range is 90.08 meters. And let's see if that correlates with the answer. In which case, so 91, yes it does. Okay, so for any other questions, go ahead and email me, shoot me a remind, whatever you need to do. But be safe, there is a big thunderstorm coming in. So, all right, thank you guys, and I'll see you guys tomorrow in class.